Well, dear friends, thank you for joining tonight for another online science cafe hosted by the KITION Planetarium Observatory, as we usually do every last Tuesday of every month. And we have a special guest, a special speaker, talking about different subjects and about the upcoming events. Tonight we have with us our space scientist here at the KITION Planetarium Observatory, our friend and colleague Ekaterini Demetriou, or Katie, as we call her, and she's going to talk about us about the latest discovery about the better to say about the latest release about life on Mars, and she will also talk to us about Giordano Bruno as she experienced visiting his statue in Rome. And also she's going to talk about the upcoming events. And after that, we have a small surprise. As you can see, we have another young lady with us tonight, Andrea Boldureanu, all the way from Romania. And I will announce her later and devote some time for her. And she will be our guest speaker next time, but I will reveal everything at the end. Thank you, Andrea, for being with us. She almost managed to visit us last Saturday because she was over for holidays in Cyprus. And her parents contacted me during the event we had for the celebrations of the 16th anniversary of our science center, the KITION Planetarium Observatory. I would also like to publicly thank my colleagues, Alexander, Katie, Chris for his sponsorship for the projectors, and all the people who came. Unfortunately, we were overbooked. We couldn't fit all these people. Some people already experienced it, and we were overbooked and people were waiting outside. Then we managed to feed some more, and then more people joined during the observations. So it was a pleasure. And for those who saw the cake, it was excellent. And now the fake part of the cake, we put it in the exhibition for everybody to see what they miss. So, Katie, the stage is yours. So please tell us everything about life on Mars.
So, hi everyone. I'm going to speak about the things that George said. Thank you for having me, George, to speak about this.
Great pleasure.
The topic is life on Mars, and then I'm going to follow that with a short piece about Bruno, who I actually visited quite recently, his statue. So just to introduce myself, I'm a space scientist. So I'm going to talk about astrobiology with the slant of a space scientist, because that's what science is. And so here you have a beautiful photograph of Mars, and basically, why are we investigating Mars? Why have we sent so many missions to Mars? And what is astrobiology? Well, astrobiology is a special biology that's about the origins of life. I mean, we are on this planet. There are millions of other stars, billions of other stars, billions of other planets. And it's a very fascinating topic to find out where we came from, how we evolved. Is there life in the universe? Is there a distribution of life? And looking for the signs of life. Now, here you have the surface of Mars. And on this is this beautiful rover, still operating very well. And it's almost been 4 years on the surface, sending us amazing images. Now, to do astrobiology, to try and look for life in the universe, we have two methods. One is remote sensing. So in remote sensing, we take missions, we take telescopes, we send satellites around different planets, or we look at different solar systems with telescopes to observe there could be any chemical signals for life, and also to look at temperatures and data about atmospheres, etc., to see if these regions of the universe would be suitable for life. So there's a lot of advantages of remote sensing. You're looking far away. It's quite a simple technology to do this. Ground-based telescopes. If it's James Webb, okay, it's a little bit more complicated, but we're getting totally. Now, that has to be backed up in some way, and we also have an in situ methods of finding this data. That means sending a probe or a lander onto an object that is fairly close to us, and one of these objects is Mars. Okay, so this is a past mission, the Mars Global Surveyor, and this is one of the 50 missions that have been sent to Mars to observe what's going on. And this particular mission actually confirmed the fact that there were features that looked like rivers on Mars, and took photos in very big detail. This is an example of remote sensing. Okay, so we have lots of cameras from a mission that's far away, no probes, no analysis, but it's pretty obvious what's going on.
May we mention here that KD worked for remote sensing at the European Space Agency.
Mm-hmm. Now, here are some images from that particular mission. So that mission was like actually about 20 years ago, and it's in the particular region on Mars. And you can see here that you have this canyon and you have these features that look just like a river flowing on Earth. And so that's the kind of data you get from remote sensing. And you can also detect radiation from the planet and analyze it and look at various signals and go together. Okay, now moving on to in situ. So here are some, if I can see my cursor, can you see my cursor?
Yes.
Oh, yeah. Okay, now here are some of the in situ probes and landers that have actually landed on the surface of Mars. So this is called InSight, and this now has reached the end of its life. I don't know if you remember, a few years ago, it was a very exciting mission where they found out a lot about the geology inside Mars. So here you have Perseverance and Curiosity. They're the two rovers that are still operational, and the main part of this presentation is all about this one here, Perseverance. So, okay, now I found this map very interesting. So it shows you the sites where the various landers and various missions, they could have been successful or unsuccessful, landed. So some landed at the top, the poles of Mars. Most of them landed on areas that you see here that have pocketed, they're marked. Interesting features to study. Currently, the two ones that you see in red are the two ones that are operational. So the European Space Agency has landers land and take some read. USA has been very successful, NASA, and this one in yellow, it was a joint ESA Roscosmos mission, but it had to be postponed because of political events. So I believe that Rosalind Franklin is going to be launched probably in 2028. And if you see the name Rosalind Franklin, I don't know if you're familiar, but she was actually one of the people that researched the double helix structure and came up with the actual discovery of the DNA. So that's how important astrobiology is to space science and space agencies in general. So why Mars? Why not just keep going to Venus or keep going to Mercury, etc., etc.? What is so special about Mars? Why is Mars so fascinating? Why look for life there? Well, for a start, Mars is not that far away from us. We need to know everything about Mars because it's actually kind of similar to our planet. So it's the fourth planet from the sun. You see it here. It is 1.5 astronomical units, whereas Earth is 1 astronomical unit from the sun. So it's like just 1.5 times further than we are. And if you can see that data there, we are 150,000 kilometers away, whereas Mars is 229,000 kilometers away. So, okay, it's not close. It takes about 7 months to get there in a probe, but it's not that far away. Now, the second thing that is interesting about Mars is it's fairly similar in size to the Earth. As you can see here from this graphic, the diameter of Mars is, okay, it is smaller, but it's not that much smaller. It's bigger than the Moon, smaller than the Earth. So it's similar in size. Its atmosphere is different in composition, but it actually does have an atmosphere. Okay, so our atmosphere is a lot denser than Mars's atmosphere. We're a bigger planet. We can hold on to more atmosphere, but Mars actually have one. And in the past, we believe that Mars's atmosphere was more. And this is the big one. So space is cold. It's a cold. Mars can fluctuate from quite cold, minus 140 to 30 degrees. And so it can have temperatures where water is not frozen. Okay, so if you look at that, we over that temperature scale is below Earth's on this. And there's a big overlap in the temperatures on Mars and Earth. And that is extremely important since we have life on Earth, the temperatures we have on Earth, then why not have life on Mars? Or why could there not have been life on Mars in the past? It has an atmosphere, it's similar in size. Earth, it's rocky like Earth, and those factors that I just discussed are very, very promising in the search for life. Now, the latest mission on Mars has been operating for over 3 years now. It's Mars 2020, and the rover is called Perseverance. Here it is. This was actually a selfie taken in the first few months of its operation. Recently, I mean, every so often there's updates on its status. Sometimes it gets dusty, it cleans itself. It's vastly superior to anything else that has ever been on the surface. I mean, if you look at this image, you can see how clear it is and how much data is getting back down to Earth. So this has helped astrobiologists find out a lot about the surface of Mars, a lot about the minerals on the surface of Mars, and a lot about how the composition of rocks is, and if there was actually water in this area. So its science objectives are 4. It's not only there to study geology, it's there to study the geology of the planet, and it is actually drilling and storing samples. So there's a sample return mission in progress where the samples that have been taken by this lander. This lander is drilling, putting them in titanium hermetic capsules and leaving them around the surface of Jezero crater. Then in the pipeline is a mission to come and pick up these samples and take them to Earth. So that is totally in situ, lovely. You've got actually a sample of Mars, an untouched sample of Mars that hasn't been through the rigors of, say, like a meteorite hitting the surface from Mars that has undergone some chemical transition of the high temperatures reached as it enters the Earth's atmosphere. Also, one of Perseverance's science objectives is if we don't find life on Mars, if we don't find any fossils or any evidence that there was life on Mars, eventually humans will be there. Okay, so probably, I don't know if you're aware, but there is a big drive for humans to actually leave the planet and start looking at moving and investigating and using the results of other objects in our solar
Probably
system.
because soon we are going to destroy our own planet.
Well, so one of these science objectives of Perseverance is to prepare for humans. Even if we don't find any evidence of life on Mars, there will be life on Mars eventually. Okay, so here's the equipment on this rover. So there's the mast cam, which is those massive cameras there that I'm going to talk about, a laser micro imager, a weather station, a subsurface radar, an oxygen generator, an X-ray spectrometer, and a spectrometer, an ultraviolet spectrometer, Sherlock with the camera Watson.
Kelly,
Yep.
if I may interrupt you, just to mention that some of the spectrometers were developed by Dr. Athanasi Konomou from the University of Chicago, who visited us, and we have good collaboration.
Yes. So like he was he did like lots of research on Mars pre-rover as well. Yes. Yeah. We've had the pleasure to meet him several times as well on his visits to Cyprus. Yeah.
We also have his signatures here, two of his signatures here on Mars at the Planetarium. And he visited us last June here.
Okay, so here is site that was chosen rover to land on. So this is Jezero crater. So it's very similar to some of the valleys, the river valleys that you see on Earth that end in a delta. So based on the previous research, the previous like remote sensing that was done on Mars and the studying of the surface and the observations with telescopes, etc., astrobiologists, in fact, inputted a lot into this decision to actually land the rover here, because as life on Earth originated in water, this area, it very probable, especially with all the research that has been done since the lander landed, that there was water in this delta. So the delta is here, and the river leading into the delta, you can see this lovely windy shape. You can see like features that would show that there was minerals deposited there. And here is what it may have looked like in the past, filled with water. Okay, so here is another picture of Perseverance, Percy, and the little helicopter. So it's the first object that was able to fly independently in the atmosphere of it. Unfortunately, the helicopter no longer works, but it was good while it lasted. So it's a technology that could be developed further, because that helicopter could go a lot quicker than the rover can on the surface. So it was moving big distances really quickly. So it could be used as a scout in the future to scout where the rovers could go. And here is some of the detail that the cameras can pick up on. So the insert here has a scale of 50 centimeters at the bottom. So you can see that that rock is about meters. Those two rocks are about 50 centimeters apart. The rock that's sticking up is about 25 centimeters tall. Now, if you look where it comes from, you can see what resolution, what kind of quality these images, these images and these data have. So it's sent down back to Earth, and in fact, a lot of this data, in fact, most data is public access, so you can use it for research. Students can use it, and it's on NASA's website. So if you go to this website here, you have all the multimedia images coming from the rover and a lot of other data. You can find a lot of other data. It's all open source. Now, even this picture here shows evidence that there was water flowing, or that there was something flowing to make that particular shape. I mean, why would the rocks be curved like this in that particular direction? Now, I'm coming on to the latest now. So this another piece of evidence that there was actually water in this crater, so in this Jezero crater. So here you see an image of something called the Delta Scarp, and it was done using 2 of the cameras on Perseverance. So you can see on this image that it seems like there are sediments, there are layers deposited. And we know from our studies of the Earth that these kind of features, they form because water brings sediments and deposits it to form sedimentary rocks. Okay, so you've got 2 different instruments, in situ data, showing very similar features to Earth. And also, if there was water there, which it seems obvious that there is, that there used to be water there, that if there were any forms of life there, they would be in the silt, so in the very small stones at the bottom. And this is one of the samples that Perseverance rover has taken. So Perseverance rover has taken samples of the silt at the bottom of this feature, ready to be picked up to be studied in the lab on Earth to check if there's any microscopic fossils. So this is one way of, scientists would really strongly think that maybe there was life on Mars in the past, because there is lots of evidence that there were lakes and there were water features, and Mars had areas that had to be warm, and there's also frozen water underneath the carbon dioxide ice caps, so that's been detected. Be excellent if those samples could be picked up and taken to the lab and studied thoroughly. We'd find out a lot about if the theory that there was life is actually true. Here's another one of those features. So again, I mean, for me, I look at this and it reminds me of the area between Seri and going on to the motorway on the way to Larnaca. So it looks like, for me, this looks like some of the rocks that are just around in my area. So looking up, you see that there's been deposits of layers. You see that the rocks on the bottom of this valley feathered, and it's coming from 2 different instruments. Now, here are 2 places that samples have been taken. So it's Wildcat Ridge and Skinner Ridge. And I'm just going to show you where Perseverance is now. Okay, so for this presentation, like I said, I used NASA sources for all of the material. It is actually here at the moment, Sol 1068. So that means it's been 1068 Martian days. And if you zoom in, you can see its path in detail. And where it was at certain points. So I believe that it shows everything. Now, this journey has been 27 kilometers in total. So 3 years of observations of 27 kilometers with 23 samples dug in different areas of this feature, this Jezero craters. So some were dug in the flat bit of the crater where the sediments would have been deposited. Some are dug in this region that is flowing from that particular valley there that was once a riverbed. Okay, so very, very interesting, and it's someone's job to drive the Perseverance rover. That's such a cool job. Okay, moving on to here you have a picture of Andy Kazja from University of Cincinnati and his graduate research student Andrea Corpolongo. They're with a telescope from Cincinnati Observatory. Now, they actually analyzed some of the data from the rover, and this guy Andy, he was one of the people who suggested that the Mars rover land on Jezero crater, and he published a paper in January that revealed very strong evidence that Mars may have also had hydrothermal systems on its surface, based on the measurements from the ultraviolet and fluorescent instrument Sherlock. Okay, so here's some of the data, and you can see that it actually gives you magnesium, calcium, and a very high sulfate region, a high sulfate peak. And this is extremely exciting, and this is what all the fuss was about. So a month ago, there was a huge fuss in the media saying life had been discovered on Mars. No, life hasn't been discovered on Mars, but it's further evidence. What has been discovered is further evidence that the conditions for life and the water and very similar things that we see on Earth were actually happening on Mars in the past. And here is a picture of a hydro vent on Earth. So biologists believe that life originated in the ocean and ran around these hydrothermal. And here you have a hydrothermal vent on Earth with that yellow mineral, which is sulfur. Okay, so this paper that they published actually shows that on Mars they had similar conditions. Life began on Earth. Okay, so that was the latest research, and the evidence that there could have been life on Mars is gathering. It's becoming more and more. Okay, but it's still evidence. You know, we haven't found life on Mars. We haven't found anything fossilized, but those samples, they're going to come back eventually, and it will be really interesting to analyze them and see what they contain.
Incredible presentation, Katie. Thank you very much. It was really, really impressive. All the news were shown directly to the point, directly to the target, and it's really impressive that we're getting more and more information looking for the fossils. And it's really, really, also the first thing that came up to my mind is those sediments actually, you know, in Nisu or in Limgia area. It's everywhere in Cyprus actually, because we have mainly limestone reefs and coral reefs and all these sediments layers are visible from the highway. So yes, it's really, really beautiful.
Yeah, so it's I mean,
it wouldn't take long, I believe, to reveal something new.
Well, I like I said, even if life isn't discovered, eventually life will be on Mars because we will go.
Yeah.
I mean, it's such a strong count. Something. Okay, there's Europa, there's the moons, there's the icy moons of Jupiter and Saturn, which is also really exciting. There was the stuff done on Venus 2 years ago when they found some signatures of that may have been generated by living organisms. Okay, that died down a bit, but it is such an exciting time, and it's a really good field for someone to go into, and it's a developing field. Like all of space science, astrobiology is a really developing field with lots of interesting work to be done.
I remember lately, when I say lately, I mean a couple of years ago, in some remote volcanoes, in some ponds where there was sulfur and sulfate and some other minerals.
Mm-hmm.
They believed until that time that they couldn't find any microorganisms, but they really discovered some. So they said that yes, this may change the view that we have for the universe and life on other planets, because we were not searching for life in those places.
Yeah.
So now the options expanded.
Mm-hmm. I was recently, and a few days ago, I came back from Rome, and one of the places that I had to go and see was this statue. Okay, so I had to go to this place. It was a marketplace called Campo de Foro, a flea market, but I didn't go to shopping. I went to pay respects to this particular person, who was a philosopher who had some very novel ideas and was a thinker who was influenced by Aristotle and Plato. And unfortunately, he came to quite a tragic end. So I'll just tell you a little bit about him. Okay, so he was an Italian philosopher, mathematician, and astrologer, as well as astronomer, from 1548. Now, around that time, you had the development, the Renaissance. So you had people who were actually thinking about what was going on. You had a big scientific revolution. You know, there was very good lenses being made in Holland. It wasn't long after that Galileo was using his telescopes to look at the universe and look at our solar system, Jupiter. Bruno studied philosophy and theology at Naples, and he was influenced by the philosophy, by basically the Greek philosophers and philosophers. Yeah. And so here are some of his ideas. So he proposed that there was an infinite universe. He thought that there could have been multiple worlds and parallel universes. He had the idea that the stars were actually little suns. So he didn't actually, he was influenced at the time by also the other Italian philosophers and thinkers that were actually starting to use science. Now, obviously, this did not go down well in Rome at all, because these ideas and his thoughts about what was going on around him, they actually were against the beliefs of the time. And he was arrested. Okay, he was arrested by the Catholic Church. He had also some ideas as well that were not that accepted, other ideas as well. He was accused of heresy and he was burnt at the stake. Okay, so he had a tragic end. They tried him, and if you look at the statue on the previous page, there's like scenes from his trial, and on the other side there's actually shows different parts of the trial, different parts of his life. So each side had a different mural on it, and it actually showed, you know, the final one as well. Now people were commemorating him because he was executed a few days before, like a week before I actually went there. They were commemorating him still by laying wreaths and stuff, because it's someone who was a martyr to his thinking. And so it was very moving to me to actually go. There was a little bit of back history as well that I learned about the statue itself. So the statue itself was constructed in the early, and the Pope tried to stop it, but the politicians of the time persuaded the Pope not to stop the statue. And the Pope apparently locked himself in the Vatican for days to complete. Okay, so that's a little bit about Giordano Bruno, a philosopher who could have been called one of the fathers of cosmology, actually.
I have a question about
Yeah.
Giordano Bruno.
Mhm.
So I know that him and Copernic lived around the same
Yeah.
time, but why was he persecuted? While I think that Copernic was actually regarded as a great scientist while he lived, so he wasn't as persecuted, or he wasn't executed by
Yeah.
Giordano was. So what
Well,
was the difference in how the people perceived the two scientists at their time?
Copernicus, he was actually very reserved, and he didn't. I believe that he was more reserved, and he did keep himself more to himself. Yes, he was celebrated more after his death. So I believe he published his main pieces of work. He published them like on his deathbed, and also like he was also Polish, so he was from further up north, even though he did travel through Italy and did a lot of studying in Italy. In fact, 1.5 years ago, I went to Torun, to Copernicus's town, and like just visited some of the monuments for him as well. But yeah, they were the same time, and Bruno knew of Copernicus's ideas, but he was unfortunate to live in Rome and have he didn't only have ideas just about the cosmology of and the suns and stuff. He also started challenging Christianity itself. So he was a philosopher who was challenging Christianity itself. And I think that's why he was tried and burnt. Whereas Copernicus was safer up north. Yeah, so it's very interesting, isn't it? Because it overlaps with Leo as well, who also had big issues with the Inquisition as well, and was held under house arrest for some of his work. And it's good that you raised that observation, because yes, they lived at the same time.
Thank you.
You're welcome.
We have the International Planetarium Day on the Sunday, the 10th of March, where we celebrate the International Day of Planetaria, of course, and we have some events celebrating this outreach and outreach events, etc. We have the celebrations of about Yuri Gagarin's birthday. Alexandra, you want to say something about it?
Actually, it's a really impressive moment because of the 9th of March, just in a few days, there will be a 90th anniversary of birthday of Yuri Gagarin. Of course, when he was born, no one knew which change in human perception he will change. Because of after his flight, we may say that now humanity changed its status. Instead of just being part of planet Earth, it's a human start conquering the space. So that's why it's a really impressive and important day for everyone who are on the Earth civilization.
Did you say the 9th of March?
Yes, 9th of March.
Saturday.
So there are some eclipses coming up. Unfortunately, we can't see them from Cyprus.
Unless we visit North America.
Yeah.
Mexico and Canada.
Is anyone here from North America or Mexico at the moment?
No, they didn't join from the University of Florida today.
Yeah, okay. Oh, well.
So on the 8th of April, we have the solar eclipse. I will cross the North America and passing over Mexico, United States, and Canada. And what else? We have anything else?
I thought you said you were going to cross to North America, and I got excited. Oh, you're going? No, you're just going across. Okay.
We wish.
Yeah.
We also have the celebrations for the Earth Hour. This is the best hour for Earth, as we say, where every year we gather here and we talk about the effects of light pollution in our everyday life and the planet. So this year we're going to celebrate it on March 23rd, on Saturday again, 8:30 in the evening until 9:30. Everybody all over the world, they should turn off their lights. So at every country, at their local time, 8:30 in the afternoon, in the evening, they have to turn off their light. Now, this is a moment of unity that brings the world together, the shine spotlight on nature loss and the climate crisis, actually. And the point, the mission is to inspire more people to act and protect the planet. And this year they found a worldwide sponsor, a well-known company, Epson. Everybody, I believe, until now they bought an Epson printer at home. So they are sponsoring. They are the worldwide sponsors for the Earth Hour 2024 this year. Alexander, you want to add anything? We have a partial lunar eclipse in September 18, 2024 in Cyprus. But,
that we can see from Cyprus.
Yes, but we are going to mention it in August for sure. Ladies and gentlemen, tonight we have with us our guest from Romania, special guest, Andrea Boldureanu. She achieved an exceptional result obtained at the International Astronomy and Space Science Olympiad for juniors, the first edition, actually, the first time it was organized in the year 2022. All countries that participated, they were there in personally, except Canada, I believe, as I read from the paper in Romania, that they were doing this online. So this first edition of the International Astronomy and Space Science Olympiad for juniors was held between October 31st and November 7th, 2022. And our friend here, Andrea Boldureanu, from the 9th grade, those times. Now we are a little bit older, Andrea, yes? And she achieved the first prize, a gold prize, actually. And here on the top, we have the an extract again from the presentation. The first prize and gold medal at an international competition is an exceptional result both for Andrea Boldureanu and for the teachers of the Center of Excellence and the National College of Iași, taking into account the fact that for such competition, the student needs knowledge of inter and transdisciplinarity, mentioned Professor Irina Zamfirescu. So she's a school inspector for physics. It's good to mention that Andrea was prepared by Professor Dr. Petru Crăciun and Professor Cristina Carmen Prinza, and they deserve our congratulations as well. And this also, it was said that this proves the confirmation of her passion for unraveling the mysteries of the universe and so on. But this was shown to us last week because she was here for with her parents for holidays in Cyprus, and she tried to visit us. Unfortunately, it was overbooked. We didn't have. It was fully packed. Even people standing, we couldn't even accept any of our families here or our volunteers, because it was really fully booked, and for security reasons we had to keep some emergency exits open. So unfortunately they didn't manage, although they tried, and they were forced to leave because of the rain. Correct, Andrea?
Yes.
So so I'm willing to see you next time, of course, and it's our it's our mission to promote people of your age, the youth, the next generation, into the world of science. Here I have something that you said, but instead of saying it, it's better for you to talk to us a couple of minutes about yourself, why you chose to attend the Olympiad, what inspired you, what makes you want to get involved with the world of astronomy and astrophysics. And I have your resume here that we will talk about it in detail next month, and we will announce in a couple of minutes why. So please, can you tell us about your experience there and what made you take the decision to attend this Olympiad, and what inspired you to get involved with astronomy?
Well, I'm very happy to be here and to meet so many other people passionate about the same thing from different countries. It's very beautiful, and it just shows how astronomy can go beyond borders, to say so. And I'm not going to talk too much about the experience with the Olympiad, but it's been amazing because I got to meet so many people from other countries and meet so many cultures and talk to them about their different systems of education. And they and they were also passionate about the same thing. And I also got to experience a whole new thing. We had 4 tests, a 4-hour theoretical test, which was obviously written, a 30-minute night observational test. We went on a very high mountain in Romania. It was very cold. It was October or November, I think. And we had an observational test with a telescope. So we had to point a telescope at different objects. I think, from what I remember, it was M45, the Pleiades, and also Alberio, like, or another double star, but I can't really remember which one. And another silent map, which is basically just a map with points, and we had to sort of mark out different stars, constellations, and it's a lot about, you know, learning and looking at stellarium and sort of memorizing those facts. And a sample of the planetarium at a city in Romania. We went at that planetarium, and we also had an observational test. So we had a total of 3 observational tests and 1 theoretical one. The observational tests, the planetarium was by far my favorite one. It was very, very interesting and a whole new experience. We just went into the room, you know how a planetarium has like some sort of dome, and they projected different stars and different arrows, and we had to say which star or which object the arrow was pointed at. And it was a very cool experience. We also got these like lanterns, those red lanterns that you use for night observations, and it was very cool to sort of have this experience. I also enjoyed the observational test. I love to, you know, use the telescope, and having the chance to use one in the context of an Olympiad was a very cool experience. And it was great to see the tests, which were kind of tough. Like, we had many weird objects, not just weird, but just objects that perhaps not many people know about because they're kind of difficult. But it was a very nice experience overall to meet people from all over the world. And I wanted to say that the thing that currently passions me, that I'm very passionate about currently, is cosmology, and more particularly the history of the universe. So I'm looking forward to having a little presentation about the history of the universe. So all the way from Georges Lemaitre's theory of the Big Bang to possible theories with which our universe can end. So that's a presentation that I hope you guys will enjoy. And if you like cosmology, I think you'll really enjoy the presentation. And cosmology has been a subject that I've been reading about for the past couple of months, I think. So I'm very excited to talk to you about cosmology.
Wow, yes. Thank you very much, Andrea. Excellent talk. Yes, so next month, Andrea will be our main speaker. She will talk about the history of the universe and the formation of our solar system, and we will also announce the latest astronomy news and upcoming events. And Andrea, I have, before you leave, I have sent you on your WhatsApp the contact for my colleague in Romania for Astronomers Without Borders. To contact him, my friend Valentin Grigor, he's the national coordinator for the Astronomers Without Borders in Romania. Most probably you saw him, on the TV, and he's very popular. He's doing a lot of things about astronomy in Romania, and we have many other friends as well. And if I manage to get you in contact with Dorin Funariu, the astronaut, that he was a guest speaker for us a few years ago. He's also part of the celebrations of the Astronomers Without Borders, because in April we have the Global Astronomy Month, a celebration, worldwide celebration of astronomy. That actually this came up after the 100 hours of astronomy worldwide celebrations during the International Year of Astronomy 2009. So they came up with this organization, the Astronomers Without Borders, and the motto is one people, one sky. So we try to connect the people all over the world and share knowledge, and they are really good people in this organization, and you may feel free to share your knowledge and ask for knowledge from them, to gain knowledge from them, and it's really, really impressive. I'm sure he will do the best with you. He will promote you and help you to learn, and maybe invite you for the podcast. He's really, really active. And tell him that George Troullias from CYPRUS, the National Coordinator for Astronomers Without Borders, gave you his contacts, and he can contact me here for sure. We are exchanging mails every now and then, so I will inform him as well to expect your phone. So, dear friends and members of the Kition Planetarium Observatory, we came to an end for this online science cafe. So next one will be held on Tuesday, 26th of March, 2024, same time, 8 o'clock Cyprus time, UTC +2, and we want to hear from Andrea about the history of the universe and the formation of our solar system. Thank you for joining us. All the best.
Thank you.
Thank you. Bye-bye.
Have a nice day. Thank you, Hasrat.